Yes, great. So if everyone is able to see the screen, let us start. Let us start with what we want to discuss today. So let me just go to the full screen. All right. So we are talking about EV layouts, and we are going to talk about different configurations of EV. So basically, if you talk about electric vehicles, what is electric vehicles? It is basically a multidisciplinary technology. Now, when I say multidisciplinary, we are talking about three different branches which are involved in this EV. So if you see, we have electrical engineering. So we have students from electrical engineering who can also play a part in this. Okay, so you see the subjects which are related to the electrical engineering stream is electrical machines, power electronics, control systems, you know, battery management and charging. Mechanical and automobile, what do we have or what we can study in this, EV domain is, though I'm saying IC engine, but today we will see how and what we are going to replace in terms of this. So whatever knowledge we have in terms of mechanical and automobile, how we can apply it to EV. So basically we will see what all parts will go and what new addition will be done, so that we are also eligible enough to speak about electric vehicles. And then we have this chemical engineering, where this chemical engineering people will talk about batteries, how they are developed, different chemistries of batteries, fuel cells, and different liquid and gaseous fuels. So basically liquid and gaseous fuels, these are in terms of alternative fuels. This is again an EV technology, and battery, which is very, very important. So so basically if you see this EV ecosystem, we all can be a part of it. So basically it's basically a multidisciplinary technology. Now let us talk about configurations. Now, when I say configurations, in other words, I am talking about EV layouts. Okay. So what I am going to talk about is, I am going to talk about EV layouts. Okay. So basically, let us start with the very first approach. So when we talk about developing a EV, you know, what we think of? Basically, we will think of a converted EV. So when I say converted EV, I am basically talking about simply, taking out the engine from an IC engine. Okay. Simply, it is coming from your IC engine. Okay. Converted EV. So simply we are going to remove the IC engine, and then we are only simply going to replace the engine with some electrical components, and that is how we are going to convert it into an electric vehicle. And that is why we call it as a converted EV. So what is the downside of it? Basically, when you talk about the downside for all the EVs, downside is heavyweight. Okay. And when we just replace the part from IC engine, and when we just replace the engine by motors, we basically we lose the flexibility. Okay. And that is why basically what we have to do is, we generally we should go for this purpose built EV. So basically we will have to design an EV from bottoms up. Okay, right from scratch, we will have to design an EV. And in terms of the third part, it's basically the energy flow via the flexible wiring. Now, what does this mean is, this basically it talks about subsystems. So it is talking about subsystems. And then you see we are talking about the propulsion. So either whether it is a single motor or a multi-motor, or what type of different energy sources which are involved in terms of EV. So basically, this is just a simple introduction. So what we are going to do is, we are going to go into much details, or we are going to go into much depth of it. So the first question which comes to my mind is, how does an electric car work. So, we did speak about this EV configuration and converted EVs and all. So first thing is, how does it work? So basically what we have is, in all the electric vehicles, we have something which is called as induction motor, okay, instead of IC engine. And this electrical energy is stored in the battery pack, and this battery pack, it powers the motor. Okay, so this induction motor which we are talking about in point 1, it is powered by a battery pack. So in practice, what we do is, we use different technologies to integrate the internal components, but the core components, the architecture is the same, okay, in all the EVs across the world. So basically, your battery pack will remain in all the EVs, your motors will remain in all the EVs. Okay, so this is just a simple definition, layman's language. We are going to go into the details of it. So basically, what do they all have? They all have a battery to store the electricity, inverter to convert the DC battery power into the AC, because battery supplies us with DC current. We have to convert it into an AC current. So basically, we need an inverter. Okay, uh, we require this AC power for induction motor to work, for onboard charger, and a controller, which manages all these components. So when I say controller, we have a motor controller, okay, to control all this motor activities. So we will come to it. We are going to go into the details of it. So recent technology, development in batteries, the cut in the price of the EV battery by more than half, along with the performance, we have enhanced the performance of the battery, has enabled us uh, or has enabled the EV to make a comeback. Okay, so basically this is what it is. So if you see the picture of if I just tear down any EV, so basically this is how it will look like. So this is the top view, and basically this is the side view of it. So you see, we have so much of storage. So we have this space, we have this space, we have this space. All this space is for battery. We have this aluminum space frame, okay, again to make it lightweight. Okay, then we have this air spring and damper. Maybe we can have different technologies. We have electrically assisted rack and pinion steering. Then we have this, you look at this electric motor. Okay, we have this power inverter. So we are talking about power inverter, we are talking about differential. And you see the entire space is just reserved for battery. So just imagine how huge the battery pack is. And if you look at this diagram, you all will agree that the layout of EV is something different from what we know in terms of IC engine. So that is the whole idea. So let me just get back and let me just go back to the let me just go back to the screen, and let me just ask if you have any questions, or are we okay up till now? Uh, does anyone has any question? So basically, again, we are talking about the background. We are just building the background to understand what is the need to study the layouts of EV and how are they different from your basic IC engine layouts. So all of us here are either a third year or a BE or a pass out student. So basically we all know that in IC engine, in automotive systems, we have spoken about the systems which are used for IC engine vehicle. So today we are, we are going to talk about, the layout basically, okay, for EVs. So that is what the whole idea is. So again, if you see, there is this EVs can further be subdivided into the type of drives. So the question which someone has asked, that why there is a space in the front, okay, why there is a space in the front. Basically, we are talking about the weight distribution. Okay, it depends what type of drive you have, either whether you have a all-wheel drive, whether you have only rear wheel drive. Majority of the EVs have a rear wheel drive. Okay, and that is how we can talk about. So the question which you are talking about, basically the answer is, we have to talk about weight distribution. So just think of it as a problem in SOM. So shear force and bending moment. We are talking about how to distribute the load, and then how to go about proper space utilization and distribution. So this diagram is just to give you an idea. Okay, so we are going to go to the depth of it. So with this, let us move forward. So maybe all the questions in your mind will slowly, okay, I will try to answer all the questions when it comes to the layouts today. Okay, so should we go back and should we start with the further slides, everyone? Okay, great. So let me just go back, and let me just, so in between, after always, after every 5 or 10 slides, I will come back and check if we have any questions. So to answer the question of the, I think Abdul Ahad had asked the question that, why it is empty. So let us talk. So let us speak in terms of, what remains. So if we change from IC engine drivetrain, so if we go from IC engine drivetrain, if we go to EV drivetrain, what remains, okay, what is added, and what goes away. That is what we are going to talk about in this slide. So basically, let us start one by one. So if we talk about body and frame, what we can do is we can keep the existing IC engine body and frame if you are only replacing the engine with motors. But if you are selecting, or if you are redesigning the car from scratch, basically you will have to redesign the entire body and frame from bottoms up. Okay, so it remains. So basically, if I compare what from IC engine and EV perspective, what all components remain in the car. So body and frame will be there. Okay, wheels definitely should be there. So all the components of rim, hub, knuckle, tires shall be there. Okay, but reselection is necessary as the weight goes up. This is important. So when we are talking in terms of wheel, we need to think, or we need to take into consideration the weight as well. So if you compare it with IC engine, simply in layman's language, wheels will remain. Third, doors and windows. So existing doors and windows will be there, or what we can do is we can have power windows, because we have the electric capability now. Suspension system, either we can use the existing, or it can be upgraded to active or semi-active types. Okay, active suspension, basically when we talk about suspension, we are using passive suspensions in majority of the IC engines. Okay, so passive suspension basically does not give you the basically when we talk about suspension, we don't want our wheels to leave the road surface. Okay, so this active and semi-active suspension, basically why don't we use it in custom cars or in basic passenger vehicles, is because they require more electricity, and in EV vehicles we have that more electricity. So basically either we can go with the existing setup, or we can upgrade it to active and semi-active type. Steering systems. So what happens is steering system remains, but the existing hydraulic power steering, now it moves to electric power steering. So you have seen slowly all the vehicles have electric power assist. So that is how they are moving component by component. All the companies are moving to this. So in terms of steering in electric vehicles, we can have electric power steering. Braking systems. So existing hydraulic brakes can be converted to electric braking. So electric braking, when I say, we are also talking about regeneration. We are also talking about the braking which is happening, electronically. So all the mechanical components are slowly getting replaced by electric. Safety systems, all the airbags and sensors will remain, with new addition towards the connected and autonomous vehicles, because your EV is the first step towards this connected and autonomous world. So all the existing sensors will remain with safety systems, but then there will be some new addition when it comes to the connected and autonomous system. So wiper and fluid pump, existing technology still remains. Mirrors, basically now they will move to electronic mirrors. Okay, but when it comes to India, we can keep it as it is to optimize the cost. Interior, all the interiors, including seats, seat belts, AC vents, cabin lights, and all the other components, they still exist in EV as well. So basically, this is a fair idea of, if I want to shift from IC engine to EV, what all should remain. The next slide, this left side talks about what is modified, and right side talks about what is replaced. So what is modified? So basically your AC, air conditioning system, okay? Nowadays, or in IC engine, you are using the power of engine to run the AC. Now that can be changed to something which is called as electric air conditioner, EAC. So what we can do is we can simply shift to variable speed DC motor instead of the existing hydraulic actuated AC compressor, because for running this AC compressor we are using the energy from the engine, so that can be replaced by motor. Cooling system, this cooling system, whatever we have in IC engine, it can be reused. Okay, reused for what? For motor and battery thermal management system with electric water pump integration. Okay, so this is some modifications which needs to be done to the existing system. And dashboard will see many modifications as number of sensors and actuators will increase. Okay, and slowly we are shifting towards the electronic control of components in terms of electric vehicles. So these are the systems which are slightly modified. So if you go to the last slide, we see all this system remains. These 1, 2, 3 will be modified. Now what are replaced? So fuel tank, we no longer require fuel tank, okay, because we are not running on fuel. Engine and the associated components like sensors and the connections will be removed. Clutch and transmission, okay, it can be removed, since in EVs we basically go for a single speed transmission system. Okay, we no longer required. So in IC engine, basically you all will agree that in IC engine we require variable gearing, right? So we have 1, 2, 3, 4, 5 gears, but in terms of EV we require only a single speed transmission. Okay, we don't require variable speed transmission, and that is why clutch and transmission can be replaced. Okay, I'm saying can. We will come back when we see the layouts. We will understand either they can be there or they can be replaced. ECU. So ECU and its connection to the sensors will be replaced. Now this ECU will be replaced by something which is called as VCU, vehicle control unit. Okay, but this will go away. Fuel pump and other engine subsystems, they will be replaced. And what is added? So when it comes to, when we shift from IC engine to EV, what is added? We have now a new addition of battery pack with battery management system. So we require a reliable battery pack with BMS along with CAN communication and support. CAN stands for controller area network. Okay, we will come to it when we talk about battery management system. Then transmission system, as I said, either it can be there or we require only a single gear transmission. So high efficiency transmission with reduction system for high acceleration. That is the requirement. So that needs to be added. Electric motor, high performance electric motor for traction, motor controller. So we require motor controller for motor drive, because we need a closed loop system. Okay, we require a closed loop feedback system, and we require this IoT and telematics. So we require IoT for data collection, okay, and telematics and infrastructure to monitor and manage the vehicle. So basically, this is all parts we need to add, and we will need to add DC-DC converters as well. So efficient DC-DC converters for other systems. So when I say DC-DC converters, either there are different types of it. So either we require a step-up converter or we require a step-down converter. Okay. So when I say step-up, so basically if you want to convert your 12 volts into 48 volts, so you will require a step-up converter. Okay, step-up DC-DC converter. If you want to reduce your higher voltages to lower voltages, you will require a step-down converter. Okay, so basically the name for it is buck and boost. Okay, so and there is also a third type which is called as buck boost, a combination of two. Okay, so this DC-DC converters, so buck converter is basically it's a step down. So boost is step up type of converter, and buck boost is a combination of both. Okay, so before moving forward, okay, I will just complete this and then maybe I will go back to take questions. So as I said, ECU will be replaced with VCU. So we have vehicle control unit, or something which is called as master control unit. It is also called as MCU. So for vehicle management and safety, we will require now, very important requirement is isolation circuits, because I'm sure with whatever numbers you have seen up till now, we have spoken about 48 volts, we have spoken about 72 volts, we have spoken about 300 to 350 volts, we have also spoken about more than 750 volts. So 48 volts is somewhat safer, but when you go above 60 volts, okay, when you go above 60 volts, this becomes mandatory, isolation circuits, because you don't want any person to come in contact with high voltage systems, and that is why you will require isolation circuits. You will require charging infrastructure. So charging port will be added, and so basically either they will be of two types, these two. So there will be an onboard charger or there is an external charger. So we will see how they work and how they are, where they are placed. And the last thing what we have is software and remote monitoring, because all these components, as I said, we require a closed loop system. Okay, closed loop system. So when I say closed loop, we will always require monitoring. So all the sensor, the data which is given by the sensor, we will always have to monitor, and we will have to take the necessary action. So just a simple example, say for example, if there is something which is called as, let me talk about thermal runaway. Okay, this is one term which is used in EV very often. So if we have a thermal runaway, your isolation circuit should basically just snap the connection of that particular cell or your battery with the entire vehicle. Okay, and so that is what it is. So we require continuous monitoring of all these components which are there in electric vehicles. So with this, before moving forward, so let me just go back and check if you have any questions. Let me just go back. Is everyone okay with whatever we have discussed up till now? Okay, let me just check the questions. Okay, there are a few things. Let me just check. The suspension which adjusts the rebound, compression, and preload according to road conditions, it's electronically controlled. Yes, either they are called as electronically controlled or active suspensions and everything. Sir, as an IC engine vehicle, we can change the HP as per our requirement by tuning the engine. Is it possible in EV to change the HP? Manthan Devani, we will come to it. Slowly as we move towards dynamic, we will see how much power. I will answer all these questions. Okay, once we go forward. Telematics, Amod, it is a combination of telephone and information technology. So you're talking about GPS, right? You're talking about so many things. You're talking about monitoring a driver's behavior, right? So all these systems comes under telematics. So we will come to that part. Some motors come with BMS inbuilt. So does it come together or separate? Vijay Sharma, it depends. It depends on which motor you are selecting. So we are also going to talk about motor and motor selection, okay, in the later part of the course. So we will see. So some motors come with inbuilt BMS, and for some motors we will require a motor controller, which is there from outside. So all these things we will see as and when we move forward. So I am teaching you as if you don't know anything. So that is what my approach is. Is this approach fine? Please let me know. So for me, I am teaching you as if you don't know anything. So I'm focusing on all these small things which I am assuming that you don't know. DC-DC converters are just giving output as constant DC volt. Uh, Vijay Sharma, it's basically DC-DC converters. As the name suggests, we are converting DC to DC, but then we will see there are some systems in EV where we will require a step down and a step up type of converters for different functioning. So at that point in time, this DC-DC converters will come into picture. So up till now, is everyone okay?
Yes, sir.
Great.
Okay.
So if everyone is okay, let us move forward slowly and steadily without rushing. Okay. So then the question is, so if we see, if we spoke about what goes away, if we talk about what still remains, if we talk about what is the addition, then the question is what's the future, and what needs attention and improvement. So guys, please remember that no system is fully viable. Okay, so what do we require? So if we talk about EV, we have regeneration system in EV. That regeneration system is only working, or the efficiency of regeneration is only 30%. So can we improve the regeneration efficiency? So that is the question. So what can you do in future? So we can focus on regeneration. Regeneration should be efficient, okay, and it should recover energy during deceleration, braking, and descending. We require motor design, a good motor design, to recover as much energy as possible. Because please try to understand why I say we require motor design is because all the motors which are available in the market are basically, they are industrial motors. Okay, they are industrial motors. Motors were not made or designed for use in automobiles. So all the motors which are available in the industry are industrial motors. So we need a good motor design for their use in cars or in vehicles. Okay. Now the question is, can regeneration come close to 90%? If this happens, then your vehicle will only use the energy to overcome rolling resistance and aerodynamic drag. So I'm sure you are aware of these two terms. So if regeneration is 90%, now when I say regeneration is 90%, I'm basically talking about, all the energy which I'm using out of EV, I'm putting it back. Only 10% loss. So it means your vehicle will only use energy to overcome the rolling resistance and aerodynamic drag. It means only to move forward. That is what the energy your vehicle will use. Rest everything you are going to put it back, because regeneration, if you see here, you will put the energy back when you are deaccelerating. You will put the energy back when you are braking. You will put the energy back when you are descending. So if you are going up, you are consuming energy. When you are coming down, you are putting the same 90% of the energy back. So that is how it is. So can it be made 90%? Yes. So there is a scope. Then we require materials to make the vehicle lighter, because your electric vehicles are very heavy because of battery packs. We will require material with better insulation to reduce the heat loads, because when we talk about EAC, okay, it competes with your drivetrain for battery power. So as an IC engine, we are using some percentage of your combustion vehicle to power the AC. Similar thing happens here. So your AC is also competing with the battery. It is also going to drain your battery. And when we are taking power out of the battery is going to heat up. So we will require a good insulation. Okay. We will require good tires, and we will require a better aerodynamics to enhance the energy efficiency of EVs. So, we will require a controller and a software specifically for EVs. So we are talking about VCU design. Okay. And then basically what we are talking about is, at the end, if you see this, can we redesign every part of IC engine vehicle as it changes to electric? So basically, if you see what I was talking about bottoms up approach. Okay, bottoms up, it means we are not simply replacing the IC engine with motor. What we want to do is we have to design the EV from scratch. Okay, so that is what this point number 8 is. So that this all things require attention and improvement when it comes to EV, even in India and even in global markets. Okay, so since we are talking about make in India and all, we have to design motor in India. Okay, we will have to design all this shape, size of the vehicle in India. We will have to design this VCU software in India. Okay, and then slowly we will have to design all the components of EV in India, and that is what the FAME scheme is there for. And that is why, if you want to understand all this, and if you want to understand how to do this, we will have to start with the basic systems and configuration. Okay, so we need to understand how the EV layouts have evolved over the years, and that is what we are going to do today. So let us start with the configuration. So basically, if you see the EV system and its configuration, okay, basically I can bifurcate that into three majority subsystems. So first one is, I have, just a second. So first thing I have is electric propulsion subsystem. Now this electric propulsion subsystem consists of a controller, a power converter, a motor transmission, gear, differential, and wheels. Okay, so this is what this electric propulsion subsystem consists of. Energy source subsystem. Energy source, basically it can be a battery, it can be a fuel cell, it can be any energy source. So it basically consists of a charger, energy management system, EMS, etc., and auxiliary power system. So when I say auxiliary power system, it basically talks about power steering, cooler, heater, infotainment, all the things which we have spoken about. So what remains, what needs to be added, so all these things can be subsystem, or they can be categorized into this three major subsystems. So if I want to show you a diagram, this is how it will look like. So in this diagram, so this is a typical EV configuration. So if you see, a typical EV configuration is made up of this three types. This is one, electrical subsystem. This is two, energy subsystem. And this is three, auxiliary subsystem. So you see what comes under electric propulsion subsystem. We have electric controller, power converter, electric motor, and we have a mechanical transmission which is connected to wheels. Similarly, your energy source subsystem, it consists of your energy source, your refueling unit. So whatever energy you are using, we have to refuel that, and for that you require an energy management unit. And then the auxiliary subsystem. So we talk about power steering, all the other power requirement which we will require to, we need to supply for all the other things like lights, AC, etc., etc. Then we require this TCU. So basically, if you see a typical EV, so what are the three inputs here? So you see your electric propulsion subsystem is taking brake and accelerator as an input. So based on whether you are braking or whether you are accelerating, your electric propulsion subsystem, okay, will talk, or will connect with this energy source. Okay, so you see, I have written here, a mechanical link is represented by a double line. So wherever you see a double line, so this is mechanical link. Okay, and electrical link, it is represented by a thick line. So this is electrical link. Okay, and a control link is connected by a thin line. So this is a control link. Okay, so basically if you see, this is how a typical EV configuration looks like. And if I just replace the names with some actual components, this is how it will look like. So again the same diagram, but if you compare it with the last diagram, you see again we have this, but instead of, you see, instead of this power converter, this component power converter, now we have a three-phase inverter. Okay, instead of the electric motor, okay, what we have a three-phase induction motor. And instead of energy source, we have a nickel metal hydride battery. Nowadays we use lithium ion battery. Okay, so you just have to, you just change this diagram and you will see that. So mechanical, you see this mechanical transmission, I have fixed gearing and differential. So we have spoken that we don't require a variable gearing, we require a fixed gearing. So if you see, if I want to draw a simplified diagram for a EV, what do I require? I require a motor. Okay, I will require this transmission. Okay, I will require this battery, I will require this power converter. Okay, and that is how all these three things interact with one another. So you see, it will take input from the steering, and that is why this arrow is this. So depending on the input, this is how the auxiliary power supply will come into picture. You see this temperature control unit is again replaced by cooler and heater, right? So we are talking about battery charger. So simply what I have done is, I have just replaced the names in this diagram with something which is used in EV. So based on whether you are braking or accelerating, your electronic controller. So this is a control link, correct? This is an electronic link, right? And this is a mechanical link. Right, so this is how it is. So we will try to understand it one by one, and the reason why I have shown you this simple subsystem diagram is, you should understand what all components are going to be there and what components are going to play a very important role in terms of EV. So basically what you need to remember is, you can bifurcate your EV system under three important types. One is propulsion subsystem, another one is energy subsystem, and the third one is auxiliary subsystem. So if you remember this three, you are good to go with, or at least you can begin. Okay. Now, is everyone okay? Let me just go back, and before I move forward, let me just check. Is everyone okay up till now? Great. So I see a lot of yes. So now what we are going to do is, based on this three subsystems, okay, based on this three subsystems, we are going to see different EV layouts. Okay, so let me just go back to the screen, and after this I will come back again to take some more questions. So based on this three subsystems, again I'm saying, based on this three subsystems, I'm going to talk about the different EV layouts. So let us see the first one. So basically, if you see, there are many different EV configurations possible due to variation in propulsion and energy sources. Okay, so based on the electric propulsion, this, okay, how many types of different EV configurations we can have? 6. Okay, so based on electric propulsion, we can have 6 different EV configuration. So this is the first one. First configuration is longitudinal front engine front wheel drive. So you see, this is the front of the vehicle and this is the rear of the vehicle, and you see what components do we have here. So if you see, we have clutch. Just look at this things which are there below. Okay, so you see we have motor, we have motor, we have clutch, we have a gearbox, and we have a differential. So what are we doing here? So can someone tell me, if you just see this diagram, this diagram is nothing but, it is a direct extension of existing IC engine vehicle. So if you just replace the engine with a motor, okay, then you will have this type of configuration: longitudinal front engine front wheel drive. So what are we doing? Instead of engine, okay, I have simply removed the engine and I have put a motor, and all the other components, so your clutch, okay, your gearbox, your differential, everything is there. Only what I have done is I have replaced engine with motor. Okay, so by incorporating both clutch and gearbox, the driver can shift the gear ratios and hence the torque going to the wheels. The wheels have higher torque and low speed in lower gears, and high speed and low torque in higher gears. Now this you all know. So based on the propulsion system, this is the first subsystem, or this is the first EV configuration or EV layout which we can have. Very basic. So if you start from IC engine, the first configuration talks about simply replacing the engine by electric motor. Rest everything remains same. We will have clutch, we will have gearbox, we will have differential, and we will have wheels and everything. So this is the first configuration. Let us move to the next configuration. Second configuration is your battery electric vehicle, okay, with fixed gears and no clutch. So now you see we are improving from what we started with. We started with simply replacing the engine with motor. Now what we have done, we are doing away with clutch, so we don't have clutch. So by replacing the gearbox with fixed gearing and hence removing the clutch, both the weight and size of mechanical transmission can be reduced. Okay, so this type of configuration is not suitable, okay, for IC engine, as engine without clutch and gearbox cannot offer the desired torque speed characteristics. We will talk about this characteristics when we go to dynamics. Okay, so simply simply look at this configuration in terms of the improvement, how we are improving. So we started with simply replacing the engine with motor. We had clutch, we had gearbox, we had differential, but now we have motor, and instead of variable speed gearbox, we have a fixed speed gearbox, and we have a differential. Okay, so that is why this configuration is known as BEV with fixed gearing and no clutch. Let us move to the third configuration. Just look at this. We are improving. Now, instead of the earlier, now we have battery electric vehicle with traverse front wheel drive. So here again, we have a motor, we have a fixed gearing, and we have a differential. But now instead of the longitudinal way, we have fixed it in a traverse way. Okay, just look at this. So instead of putting it in a longitudinal way, we have put it in a traverse way. So similar to the concept of traverse front engine, front wheel drive of your IC engine, the electric motor, fixed gearing and differential, they are integrated into a single assembly, while both the axles are the driving wheels. Okay, so this type of configuration is most commonly adopted type by modern EVs. Okay, so this is one of the most important or commonly adopted configuration by modern battery electric vehicles. So I'm sure you are understanding as we are moving forward. Now you see we have a split, so we have a dual motor drive. So we have battery electric vehicle. Now what modification we have done? Instead of one single motor and one single fixed gear, what are we doing? We are splitting. So we have battery electric vehicle with a dual motor drive. So besides the mechanical means, you can achieve the differential action when cornering. It can be provided by two electric motors operating at different speeds. So here you see we no longer require a differential. So the work of differential is done by this motor and fixed gearing thing on one side, and motor on fixed gearing thing on the other side. So these two motors can be rotated at different speed, you know, to achieve the differential action. Basically, when we talk about differential comes into picture when we are taking a turn. Okay, so it will give us different speeds to the inner and the outer wheels. That same thing can be achieved instead of mechanical means. We can achieve it by electrical means. And how we can achieve it in terms of electric? By just splitting the drive. So we no longer require differential now. Okay, so dual motor configuration in which two electric motors separately drive the driving wheels via fixed gearing. This is also one of the layout which is possible. Fifth layout, now just look at this. Okay, so here we are just shifting. So we are shifting this mechanical things or motor and fixed gearing. We are shifting it into the wheels, and that is why it is called as battery electric vehicle with in-wheel motor drive. Okay, to further shorten the mechanical transmission path from electric motor to the driving wheels. Okay, so whatever half shafts we will require in the earlier configuration, now we are shifting it to the in-wheel motor drive. So the electric motor can be placed inside of wheels. Okay, and along with that, what we have a fixed planetary gearing is employed to reduce the motor speed to the desired vehicle, wheel speed. So this is very, very important. Fixed planetary gearing, and your planetary gearing offers the advantage of high speed reduction ratio as well as inline arrangement of input and output shaft. So basically you will see that this in-wheel motor drive technology, okay, this in-wheel motor drive technology is basically majority it is incorporated for two-wheelers, three-wheelers. Okay, majority of the times it is incorporated for two-wheelers and three-wheelers. Okay, so because it becomes, this system is very, very complex. Okay, so inner rotor type is used in modern EVs, and outer rotor type is used in two-wheelers and three-wheelers. We will see what it is. Okay, but this is just one configuration. So, and the last one, so this, you see, this is the inner rotor type, and this is the outer rotor type. So you see this, by fully abandoning, we are simply, we don't have any mechanical gearing. So by fully abandoning any mechanical gearing, the in-wheel drive can be realized by installing a low-speed outer rotor electric motor inside a wheel directly. Okay, this is basically a gearless arrangement in which outer rotor is directly mounted on the wheel rim. So we are rotating the wheels directly with the help of motor. Thus, speed control of electric motor is equivalent to the control of wheel speed and hence the vehicle speed. So, advantages, if we simply control the speed of electric motor, that will take care of the wheel speed as well as the vehicle speed. Why? Because it is directly fitted into the wheels. Okay, so with this, let us just see how we can improve. So I will just play, I will just go through, once again from 1 to 6, you see how the improvement can be done. Okay, so first thing, started with IC engine, replacing IC engine with motor. We still have clutch, gearbox and differential. Okay, in the second one, we have cancelled, or we no longer require clutch because we have moved from variable gearing to fixed gearing. So we only require motor, fixed gearing and differential, but that is placed in longitudinal way. Next, we can place the same arrangement in traverse way and we can achieve front wheel drive. Okay, fourth, we no longer require differential even. Why? Because now we have a split drive or a dual motor drive. So here we no longer require differential. Okay, we still require some mechanical means, because we will require, we still have this half shafts, which are connecting the wheels. So we still have some mechanical links here. So even to do away with this mechanical links, uh, what do we have? We have an in-wheel motor drive. Okay, and then the last one is we have an outer rotor motor drive. So directly your motors are fitted onto the wheel rims. So I hope, let me just go back and check if we have any questions, and then we can move forward. So based on the propulsion system, okay, again we are saying based on the electric propulsion, this 6 configurations are possible. Okay, did everyone understand? Yes, it's a hub motor. Yes. So whatever we are discussing is we are discussing the layouts. Okay, any particular company is free to select any one of this layout. Okay, so the diagram which we had seen earlier, okay, the tear down diagram for an electric vehicle, okay, that was for a Tesla vehicle. So if I just go back to the diagram, okay, can someone tell me which configuration was that? So let me just go back to the diagram. Okay, let me just go back to the screen. Okay, this one. Now, I hope you are able to see this. Now, can you tell me what type of layout is this? It's a longitudinal, but are you able to see the fixed gearing? Are you able to see the two motors and fixed gearing? Just check. You have two electric motors on both the sides. You have differential. Yes, just see. So, this is for a Tesla. Okay. So what I mean to say is, or what I want you to understand is, any particular sedan or any particular two-wheeler, three-wheeler, or a four-wheeler, okay, can select any one of this configuration or layout. Okay, it depends on how do they design. Okay, if they design it from scratch, they will have all the freedom to select any one of this configuration. That is what I wanted to tell you. Okay, so this EV layout is on the basis of propulsion system. Okay, so based on what is powering, we are talking about the layouts. Now, should we move forward? If everyone is okay up till this point. Okay, great. So if you are okay, let us move to the configuration which is based on energy sources. So these configurations are possible based on propulsion systems. Let us see the configurations which are possible based on the energy sources. Let me just, okay. Okay. So now just see. So based on energy sources, you see this. So based on energy sources, how many configurations are possible? Again, 6. So we had 6 configurations earlier, plus we have this 6 configuration. Now you see here, these bifurcations are not on the basis of drive, it is based on the basis of energy source. So what type of energy source do you have? So you see B stands for battery, C stands for capacitor, FC stands for fuel cell. So they are going to come forward. So I'm just writing it here. FW stands for flywheel, P stands for power converter, and R stands for reformer. Okay, so depending on what type of energy source you have. Okay, so I have written, so what are the different energy sources which are possible? Either we can have a battery, either we can have a fuel cell electric vehicle, either we can have ultra capacitors, or we can have ultra flywheels. Okay, so most common what we see in EVs is this battery configuration. So BEV, this is the first one, battery electric vehicle with battery powered configuration. So it is almost exclusively adopted by all the existing EVs. So in nowadays, whatever electric vehicles you will find or you will see, you will always see this type of configuration: a battery, a power converter, okay, and on the basis of that you can have a configuration. So the battery may be distributed around the vehicle, or it can be packed together at the vehicle back, or located beneath the vehicle chassis. So the diagram which we saw earlier also, just recall that, you will be able to understand what we are talking about. Okay, it should be able to offer reasonable. Now please, uh, you know give or pay attention to this. It should be able to offer good specific energy and good specific power, because, okay, uh, reason is, the your specific energy is related to something, and your specific power is related to something. We will see what it is related to. But your battery configuration should be able to offer you a good specific energy and a good specific power. Okay, as well as it should be able to give you, or it should be able to accept the regenerative energy during braking. So high specific energy and high specific power are desirable for EV applications, as your high specific energy is related to your driving range. Okay, whereas your high specific power, it dictates the acceleration rate and hill climbing capability. uh, at least I will want you to make a note of it, that your high specific energy, okay, it governs your driving range. So whatever specific energy your battery is able to provide you, you can you can relate it to the driving range of the vehicle. and whatever specific power your battery provides you, that will dictate how much acceleration you can achieve or how much hill climbing capability you can achieve. So if you see any electric vehicle specification, they will always tell you 0 to 100 in 3 seconds. Okay, they will always claim that 0 to 100 in 3 seconds. What does that mean? They are talking about high specific power, because that is what is dictating your acceleration rate. Okay, so 0 to 100 meters in 3 seconds, so we are talking about high specific power. And when they are talking about range, so you see all the EVs, basically they will always speak about range. So Hyundai Kona, it talks about 500, say for example, it talks about a range of 500 kilometers, right? And it talks about 0 to 100 meters, or 0 to 100 meter per second in some time. So basically what they are talking about this high specific energy and high specific power. And who gives this who gives this high specific energy and high specific power? It is given by the energy source. So either it can be a battery, either it can be a fuel cell or a capacitor or a flywheel. Okay, so a battery having a design compromised between specific energy and specific power is generally adopted in this configuration. So again, if you see, you cannot have both. You cannot have high specific energy and you cannot have high specific power. Okay, and that is why what you will have to do a compromise. You will have to do a compromise between specific energy and specific power. So either it can give you a range, okay, and it will not give you the acceleration rate, or if your vehicle gives you the acceleration rate, then it will not give you the range. Okay, and this altogether depends on battery chemistry, or the chemistry of the energy source. And that is what we are going to see also. What are the different types of battery chemistries which are available, and how they perform in terms of specific energy and specific power. So these two terms are very, very important. Okay, please make a note of it: specific energy and specific power. So this is first configuration which is possible. Let us see the next. So next configuration is battery electric vehicle with hybrid batteries. Now what is this hybrid batteries? Okay, so just now we spoke about specific energy and specific power. So what we can have is, we can have instead of using a compromise battery design, instead of compromising, what we can have two different batteries. Okay, two batteries. One is optimized for energy and another is optimized for power, and it can be simultaneously used in EV. Okay, so this arrangement not only decouples the requirement on energy and power, but also affords an opportunity to use the mechanical rechargeable batteries which cannot accept regenerating energy during braking and downhill. So rather, the problem which we had in the last configuration, that we will have to do a compromise. Okay, we can just, what we can do is we can have a hybrid battery. So one battery, so we need to have two different battery chemistries. Okay, so here we will have one chemistry. So say for example, this can be a nickel metal hydride chemistry, and this can be a lithium ion chemistry. Okay, so two different battery chemistries. So this chemistry will give you good specific energy. This can give you good specific power, and that can solve the purpose. So hybrid batteries, again, this is power converter. Okay, so this is second configuration which is possible. Third, just look at this. Now third is, we can use fuel cell as the energy source along with your battery. So all the fuel cell electric vehicles fall under this configuration. So, differing from battery, which is an energy storage device. So battery is an energy storage device. Fuel cell is an energy generation device. Okay. So what does a fuel cell do? You simply have to supply the fuel cell with hydrogen. okay, and it will give you electricity. So when I say energy generation, your fuel cell generates electricity as long as you supply hydrogen. So that hydrogen can be stored in a tank, in an onboard tank, whereas the oxygen is extracted from air. So basically, final year guys and those who have passed out will understand that your fuel cell, what does it do? Fuel cell basically it takes hydrogen and oxygen, okay, and it will give you electricity, and the output will be water. Okay, that is what a fuel cell does. And since we are going to learn it in the syllabus, I'm not going to stress much on how the fuel cell works. Okay, so but this is again one configuration which is possible. Now, why this is possible? Because fuel cell can offer high specific energy, but it cannot accept regenerative energy. Okay, so there is a limitation. So fuel cell, okay, it can give you high specific energy, so your one problem is solved, but it cannot accept regenerative energy. So it is preferable to combine it with a battery with high specific power and high energy receptivity. So either, so you cannot simply have a fuel cell. Okay, you cannot have a configuration with only fuel cell. You will require a battery. Why? Because for regeneration you will require a battery, because fuel cell will give you high specific energy, but it cannot store the energy or the regenerated energy, and that is why you will still require a battery. So this is the third configuration: battery electric vehicle with fuel cell as energy source. Fourth configuration, so here you see fuel cell is connected with reformers. Okay, now the problem with using fuel cell is supply of hydrogen. So either you need to have or either you need to generate hydrogen on board, okay, so that you can have a continuous supply of hydrogen, or you can produce hydrogen on the vehicle itself by using a reformer. So there is something which is called as a reformer, which produces hydrogen, okay, with some chemical action. So rather than storing hydrogen as a compressed gas or a liquid or a metal hydride, you can generate hydrogen on board, okay, so from fuels such as methanol or even petrol. So that is why we will install a mini reformer. Okay, so this reformer is a thing which will generate hydrogen, and this is one configuration. So battery electric vehicle with reformer and fuel cell. Next is battery electric vehicle with ultra capacitor as an energy source. So you see, you still have a battery, okay, you have this capacitor, and you have a power converter here for capacitor and a power converter here for a battery. So the fuel cell and battery hybrid, in which battery is selected to offer high specific power and high energy receptivity. So this is what we have seen in the last slide. The battery, in the battery and the capacitor hybrid is aimed to have high specific energy. Okay, this is because capacitor can offer a higher specific power and energy receptivity than a battery. So this is again one advantage of capacitor. The available capacitor for EV applications, they are usually called as ultra capacitors, and that is why I told that it is called as ultra capacitors and ultra flywheels. They are of relatively low voltage levels, and hence an additional DC-DC power converter is needed to interface between battery and capacitor terminals. So when we are talking about DC-DC, and that is why I said that you require different types of DC-DC converters. So either you will require a step up or a step down. So depending on what type of configuration you have, you will require that particular DC-DC converter. So here, you will require a additional DC-DC power converter. Okay, so this is one. And the last one is again battery with flywheel and power converters. Okay, so the flywheel is another emerging energy storage device which can offer high specific power and high energy receptivity. So you see what is common between ultra capacitor and ultra flywheel. They both are best, or they both offer high specific power and high energy receptivity. The flywheel for EV application is different from the conventional design, okay, which is characterized by low speed and massive size. So here, you don't have to imagine the flywheel which is used in IC engines. Here we will have a different flywheel design. So here the flywheel is lightweight. It operates at high speeds under a vacuum environment. Okay, so this ultra high speed flywheel is incorporated into the rotor of an electrical machine, which operates at motoring and generating modes when converting electrical energy to and from kinetic energy. So when motor works as a generator, that time this flywheel will come into picture. Now the battery is selected to offer high specific energy. Why? Because your flywheel gives you high specific power, and hence you will have a battery which will offer you a high specific energy. Okay, so this flywheel is preferably incorporated into a AC machine which is brushless and can offer high efficiency than a DC machine, and hence an additional AC DC converter is needed to interface between battery and flywheel terminals. Okay, just a second, I'm just getting a call. I will, just a second. Okay, all right, I'm back. I'm sorry. So, so this is what it is. So basically, we were talking about this battery electric vehicle with ultra flywheel as an energy source. Now, up till now, did you guys have understood what we are talking about right from the beginning? Just let me know. So we have seen configurations based on propulsion system. We have seen different configurations which are possible with energy sources. Great. So if you have understood, can we move forward? Yes. So, let us move forward with this. So in total, you see, if you just bifurcate, based on the energy sources and based on the propulsion systems, we can have 6 different configurations which are possible. At the end, you will combine these two together. So if you look at it from an EV perspective, okay, in an EV, what you will do, you will either have a battery, a power converter, okay, and one of the configuration which we have seen earlier. Okay, so at the end you will combine this two, but this is how, this is how you can have different permutations and combinations, which you can have in electric vehicle. So 6 different combinations in terms of propulsion system, 6 different configuration in terms of energy sources. So if you just see different permutations and combinations which are possible out of it are variety. Okay, so that is how it is. So so let us just go back and let us move forward to see what more do we have when we talk about this technology. So this 6, so I will just what I will do is I will take you back through all of them once again. So here you see one of the most commonly used configuration is this, a pure battery. okay, and a power converter configuration. So battery powered configuration. Either second is you can have hybrid batteries. So hybrid batteries, one battery can give you high specific energy, one battery can give you high specific power. Third, fuel cell and a battery type of configuration. Because battery is an energy storing device, fuel cell is an energy generating device. So that is why you can have this configuration. If you don't want to store hydrogen on board, you can you can produce hydrogen with the help of reformer. So this is one configuration. Another configuration is battery with ultra capacitor as an energy source. So ultra capacitor will give you high specific power, okay, and high energy receptivity. So you will still require a battery for high specific or high energy density. And similarly, ultra flywheel as an energy source. So these are the different configurations which are possible. So let us see how the power flow will be. Now, what we have seen up till now is, you see the hybridization of energy source. So when I say hybridization, we are talking about either battery, okay, with battery, or we are talking about battery with fuel cell, or we are talking about battery with ultra capacitor, or we are talking about battery with ultra flywheel. So these are the different hybridization of energy sources which are possible. So what happens during normal driving? So you see, we have two energy sources. We have one with high energy source and another with high power source. So what happens during normal driving? So these are the different modes in EV. Okay. So during normal driving, you're out of this hybrid source. Okay. The source with high energy will supply, okay, the power to the electrical drivetrain. Okay. That is what it means. So this is during normal driving. What happens during acceleration? Just see. So during acceleration, both your source with high energy and high power will supply energy. This red line means they are supplying energy to the drivetrain. Okay. So I can say simply that both deliver. Now, what happens during braking? During braking, the source with high energy source, okay, will do nothing, whereas your braking, whatever regeneration is happening, okay, your high power source, you see this HPS, high power source will absorb the braking energy. So whatever regeneration is happening, your high power source will absorb that energy. And what is the efficiency of regeneration? It is only 30 to 40% maximum I'm talking about. Okay. So your high power source will absorb the regenerative energy. So this is what it means. So, going forward, when we talk about the control systems and all, okay, you should know this. Now, you can have this type of configuration also. So here you see, we know what is controller, we know what is power converter, we know that there is a motor, a fixed gearing. Okay. Now, single or multiple motor is the same configuration when where we have seen that if you want to take a turn, okay, so whatever motor is, it will have to supply more power to W1 as compared to W2. So wheel 1 and wheel 2. So this is the inner wheel, okay, and this is the outer wheel. So your outer wheel will have to travel a greater distance as compared to the inner wheel. So depending on that also, okay, uh, we so here you see we will have a motor, we will have a fixed gear, and we will have a differential. Okay. So even this configuration is possible. Then you can also have such configuration. So you have this, a controller which is a coordination controller. So you will have two controllers here. You will have a power converter, you will have two motors and a fixed gearing. So this is one wheel, this is outer wheel, and this is something which is coordinating the inputs with these two controllers. And you have steering input or steering command which is coming from here. So based on whatever steering command you require, okay, you will tell either so say for example, if you are taking this turn, okay, and if you have this type of configuration which we have seen already, so what this controller will do, this coordination controller will tell this particular wheel W1, okay, to rotate at higher speed as compared to this wheel, because we are taking a turn. So what does this controller will do? It will do this. So W1 will rotate at greater speed than W2 if you are taking a left turn. When we are moving straight, W1 and W2 will be equal. Okay, so simply we are talking about E differential here. So this technology is also sometimes called as E differential. Okay, so this is how the control strategy is what we have. And you see, these are the various parameters when it comes to selection of motor. So whether we should have a single motor or a multiple motor. So you see, cost wise, single motor will cost you less, it will cost you high. Size, it will be a lumped because we are using only one motor. Here the size will be distributed because, you know, on both the sides we will have two motors. Weight, again, it will be lumped, here it will be distributed. Motor rating, we will have a high rating of motor here because we are using only one single motor. Here we can have a lower motor rating. Okay, efficiency, with single motor we will have lower efficiency, here we can have high efficiency. Now differential, in terms of single motor we will have a mechanical differential, whereas if you use multiple motor, as I said, it is a E differential or electronic differential, and that is why multiple motor will have electronic differential. Controllability, if you use a single motor, controllability is low, whereas multiple motor controllability is high. And reliability, here it is highly reliable, but here if you see multiple motor, it is reliability is high with fault tolerant control. So say for example, if there is some fault which is happening in the system, there will always be a fallback mechanism which will always be there in terms of that. So in terms of multiple motor, we will always have a fallback mechanism. So, you know, if you compare these two technologies, so we have already seen the configurations, and in the configuration, you have seen that either there will be a single motor or there will be a split or multiple motors. So this is one slide which will give you a fair idea. Okay. Now, again, if you compare, you know, battery electric vehicle with fixed and variable gearing, so you see the left hand side. So, you know, if you have a fixed gearing, you will have this clutch, gearbox and everything, and it will make it bulky. Okay, but if you have I'm sorry, if you have variable gearing, it will make it bulky. But if you have a fixed gearing, okay, what is the advantage? It will be light and it will have a high performance motor. Okay, and that is why one of the simplest choice is we will go with fixed gearing instead of variable gearing in terms of EV. So this type of configuration is used only when we simply replace IC engine with motor. So we have already discussed that. So let us see the comparison of the two as well. So when we talk about fixed gearing and variable gearing, motor rating in fixed gearing, motor rating should be high. In variable gearing, it can be low. Power converter rating should be high. Efficiency of fixed gearing is higher. Reliability is higher. Why reliability? Because it has less number of parts. Motor design, it can be customized, but at the same time, it can be complex. Weight and size, weight is lower, size is smaller, whereas in variable gearing, you know what happens in IC engine, weight is higher, size is larger. Cost, again, if you compare it with variable gearing, fixed gearing cost will be low and variable gearing cost will be high. And system operation as a whole, if you see, this will be a simple operation as compared to this will be a complex operation. And that is why, again, What is the fixed, or what is the choice? Choice is fixed gearing instead of variable gearing. Now let me just go back and let me just ask, are you guys clear with whatever we have discussed up till now? Everyone, I hope everyone is understanding the things as well. Yes, so all of you, are you clear with the EV layouts or EV configurations? Yes, so we started our discussion today. Okay, Dipesh, do not worry. Even if you rejoin, I am recording the session. I will put the recording on the Google Classroom. Okay, so great. So what did we start with today is we basically started with, uh, you know, what is EV. So we saw that, electric vehicle is a multidisciplinary branch. And then we started our discussion with, if we compare IC engine with EV, okay, what all components will be there, what all components will be replaced, and what all component needs to be added new. And then we slowly moved from there, and we shifted our focus on configurations. So we saw a general EV layout where we saw that, if you talk about EV system, it can be bifurcated into three important subsystems. So one is based on propulsion system. That is one. So electric propulsion subsystem is one subsystem, energy source is a second subsystem, and auxiliary is a third subsystem. And out of this three, on the basis of two, we have seen configurations, and six different configuration on the basis of propulsion, six different configuration on the basis of energy source. And at the end, we have compared that which one is better and why. So we have compared whether we should go for a single motor or a multiple motor, which is better. And we have also compared whether we should go for fixed gearing or variable gearing, which one is better. Okay, so all the pros and cons, we have seen in terms of that. So with this, should we move forward? Everyone, another 20 minutes at least, we will start with dynamics today, and then we will stop. Great. So if you have understood, so we are already 7:40. Right, so a small little part we will start today of dynamics, and then we will stop. Okay, so let us move forward. So let me just make it a full screen. Let me select the pointer. All right, now the question is how to decide the system voltages in battery electric vehicle. Now I'm sure this auxiliary battery will always be there, okay, in uh, your battery electric vehicle as well, because 12-volt battery will always be there. Apart from that, you will have these numbers or configuration. So either you will have a 48 or a 72 or a 96, 300 or 600. Now everyone, I'm sure you know where these numbers are coming from, and that is why session 1 and session 2 were important. There I have shown you that these voltages, okay, you know where the vehicles, which vehicles are, and which vehicles use this kind of numbers or voltages. Okay, so basically, what is the first, how do you decide the system voltage? Number one, it depends on motor design. Your motor design is related to system voltage. So if you talk about high voltage motors, what they will do, it will reduce the cost of power converters. Okay, you will require large number of batteries in series. Okay, it will reduce the interior and luggage space. High voltage motors, weight and cost will go up, and performance will degrade. Also, your system voltages are governed by battery weights as well. Okay, so high power motor will adopt high voltages. So again, question still remains. So as we do, so in terms of battery, you remember we will we have to compromise in terms of specific energy and specific power. So similarly, in terms of voltages, when we decide the system voltages, we will again have to do a compromise between motor and a battery. So we will try to understand slowly what does it mean. Okay, so just remember this thing at this point in time, but at least we know the number. So how to optimize? Okay, optimization is a problem. Optimization. So how do you optimize your motor and a battery, and then how you can decide the final system voltage? Okay, so whether you want to go with 72 volts, so for 72 volts you will require a specific motor and a specific battery. So which battery will give you this 72 volts, and which motor you can select on the basis of your system voltage? So all these questions we are going to answer, okay, moving forward. But before I start with that, let us talk about some few parameters which are common with IC engines, but some new addition in terms of EVs. So in general, you see most of the EV parameters are borrowed from well established definitions, which are used in IC engines. But there are some parameters which are particularly defined for electric vehicles. For example, battery weight, okay, regenerative braking efficiency, they are not present in IC engine. So basically you see, I just want you to go through these definitions. So why? Because when we will speak about EV dynamics, okay, these things will come into picture. Curb weight. So curb weight is nothing but the weight of the vehicle excluding the payload. Gross weight is the weight which is including the payload. Payload in the sense everything. Okay, so payload, you see what is the definition of payload? It is the weight of the passengers and the cargo. So curb weight, it is excluding weight of passenger and cargo. Gross weight, it is weight which is including the weight of passenger and cargo. Inertia weight, the curb weight plus a standard payload. Maximum weight, this is the maximum gross weight. Drivetrain weight, the weight of the entire drivetrain of the EV. Battery weight, now this battery weight is not defined in IC engine vehicle. The weight of the whole battery pack. So first we need to learn how to design a battery pack, and then we will talk about the weight. Vehicle dimension, this is again common: length, width, height and ground clearance. Frontal area, again you will require this frontal area which is affecting the aerodynamic drag. I'm sure everyone knows. Seating capacity, so how many number of passengers or children's. And cargo, what is the volume of cargo? So some basic parameters, which we are using almost the same, which we are using for IC engine, but with a small modification in terms of battery weight and regenerative efficiency. As I told you, I have already told you that regenerative braking efficiency is only 30 to 40%, not more than that. And battery weight, once we design a battery, then we will talk about the battery weight. So now, with this all this background of configurations, whatever numbers you have seen, whatever vehicles you know, now let us start with dynamics. Dynamics, it is very very important, because till the time you don't do this calculations of dynamics, you cannot decide upon anything. Okay, so dynamics, electric vehicle dynamics will play a very important role in selection of battery, motors and everything, because your EV dynamics will tell you, how much power you will require. Okay, how much tractive power you will require, how much energy you will require, how much torque you will require, how much speed you will require. And all this, you know we still don't know. So you cannot simply go on selecting that, okay, मेरे को गाड़ी डिजाइन करना है, मैं ये मोटर सिलेक्ट करता हूँ, ये बैटरी पैक सिलेक्ट करता हूँ. That is not going to solve the purpose. And that is why, understanding EV dynamics is very important. So let us go ahead and at least try to understand some things out of it. So whether you are driving a IC engine or you are driving an electric vehicle, these are certain questions which will always come to your mind. The questions are, these questions are very important when it comes to EV. Again, you see how much power is required to drive a vehicle. Till the time I don't calculate, I will never know. How much energy is required to carry out a road trip? This is also a question which I want to know, or answer I want to know. What is the gross vehicle weight? So, what composite mass, including passengers and goods. Now, this will not be answered till you include the battery weight. And to include the battery weight, you should know what is the power which is required from the battery and how much energy you require from the battery. So till the time you don't design the battery pack, you cannot talk about gross vehicle weight. Then what is the condition of the road? So we are basically talking about what is the rolling resistance, how is the aerodynamics of the vehicle, so what is the aerodynamic drag, how much incline will the electric vehicle will be able to traverse. So here, please understand, we are talking, or we are asking all these questions in terms of EV. So what is the gradient which your electric vehicle will be able to traverse? What is a drive cycle? Okay, so when I say drive cycle, I'm talking about what are the velocities and accelerations at different point in time, and at the end, what is the maximum speed and maximum acceleration of the vehicle. So these, again, it is coming from all the numbers which we have seen. Please recall the dashboard which we have seen. That dashboard was specifically talking about maximum speed for a particular vehicle, and it was also talking about maximum acceleration for that particular vehicle, which was under the FAME scheme. Do you all remember? Let me just go back and check. You guys remember seeing that dashboard? And you know, that dashboard was specifically talking about the maximum speed, the maximum acceleration, the battery capacity, correct? Great. So if you remember this, please understand those were all the important parameters. So now slowly we are trying to connect all the points together, and now we will start. We will dive deep into the calculation part. So, is everyone ready to do some calculations? Yes, no, maybe simple calculations, because your electric vehicle dynamics will talk, or will have calculations, because till the time you don't do calculations, you will not understand anything. So great. So yes, definitely in next lecture we will have a lot of calculations, but for today, let us see, or let us at least see, or you will be happy to know that on what we are going to calculate. So I will just show you a couple of screens, and maybe then we can close for today. Okay, so guys, I see a lot of people saying that next lecture, was it boring? Was the lecture boring? Okay, no, I understand that there is IPL and you guys have, sat for the entire day, and it is, I understand your condition, but we will have to take a break where we can stop. Okay, yes, definitely. So what I will do is I will introduce you to some terms today, and then we will go for the calculation part in the next week. Okay, so let us see what those terms are. I'm sure you all know those terms, and you will be happy to know that that same terms we are going to use here as well. So first thing, again, think from the perspective of electric vehicle. Okay, not from the terms of IC engine vehicle, because in IC engine vehicle we are not concerned, rather we are not concerned about these questions. But in electric vehicle, we are very much concerned about these questions. So what is that question? What does, uh, you know, what does a tractive force overcomes? So basically, when I say tractive force, my tractive force is made up of these four components: aerodynamic drag, rolling resistance, gradient resistance, and my acceleration. So out of that, okay, please remember that. So if you see this diagram here, so this is my aerodynamic drag, this is my rolling resistance. My rolling resistance is a property of tires which I am using, correct? Okay, just a second. Right? So my rolling resistance is a property of vehicle tires, and the weight, you see this weight is this is simple mechanics. One is along the ground, so mg sine theta, and one is mg cos theta. So this mg can be bifurcated into two components, okay, out of which one component is again resisting. So you see, and this is the angle on which my vehicle is traveling. Okay, so basically, what is that aerodynamic drag? So aerodynamic drag, I'm sure you all know the formula. It is half rho CD A into V square. So even for third year, you guys know what is this. Now, this aerodynamic drag is given in terms of newtons. Again, as I said, I am speaking as if you don't know anything. So let us see how. Okay, so this rho, if you see this rho is given in terms of kg per meter cube. Okay, CD is a drag coefficient. It does not have any unit. Area is given in terms of meter square, and your velocity is meter per second, correct? So it is meter square and it is second square, because I'm going to square this. So if you see M3, M2, and this will go away. So what am I left with? I am left with kg meter per second. So what is kg meter per second? It is nothing but 1 Newton. So 1 Newton is nothing but kg meter per second. And that is why this aerodynamic, I sometimes I call it as a force, because it is given in terms of Newton. Okay, so this is vehicle frontal area or projected area, and CD is the drag coefficient. Now, similarly, rolling resistance is given by the formula mg mu and cos theta. Okay, so what is m? M is the permissible load. Now, please think in terms of EV. Weight is again mg. Okay, and it is given by, we take it as 9.81, and mu is the rolling coefficient. Okay, this is given for different tires. So gradient resistance or climbing force, this climbing force or gradient resistance is given by mg sine theta. You see this component. Okay, so if I want to go on this gradient, if you want my vehicle to move in forward direction, okay, I will have to overcome this mg sine theta, because that is what is resisting. So I will have to calculate. Okay, and this is the maximum grade. Okay, so this theta, you see how you can convert it into radians. So I will simply multiply by pi by 180. So I will convert it into radians. And sometimes, this grade is given in terms of percentage. Okay, so say for example, you will sometimes you will be given that there is a slope of 5%. So what I will have to do is I should be able to convert that, okay, into some degrees. So how will I do that? So you see, so say for example, so grade, so this grade theta, so this tan theta is given by p by b. Okay, so grade in degrees, you see this, it is given by tan theta is nothing but p upon b, where p is the height and b is the base. Okay, so what is this? So what is theta? Theta is tan inverse of p upon b. So whatever is this grade, it is it is tan inverse. And say for example, if I am given that in percentage, so what will be my theta? So my theta will be tan inverse of I am given that in terms of percentage, 5%. So 5% is nothing but 0.05. So if you see this theta, if I just calculate tan inverse of 0.05, it is nothing but 0.0499 radians. Okay, and how can I convert this radians into degree? So simply if I multiply this 0.0499 by 180 by pi, okay, I can convert this into degrees. So if I just do this calculation, so 0.499 into 180 by pi, so that gives me something, that gives me a slope of 3 degrees. Okay, just check my calculation. Maybe this is 3 degrees. So basically what I want you to understand is, in terms when you do calculations, okay, your grade or your climbing can be given in terms of percentage, or it can be given in terms of degrees. So whatever it is given to you in terms of whatever things, you should be able to convert it from one to the another. Okay, so basically if you see what are the forces acting on the vehicle when it is in motion, basically aerodynamic drag, rolling resistance, and I will have this gradient resistance, which is mg sine theta. So hence what I can say, tractive force produced by the powertrain will first overcome these forces, and only then it accelerates the vehicle. So first thing, whatever energy, okay, I'm going to draw from battery, and whatever my motor is going to produce the tractive force, whatever tractive force my motor is going to produce, first all these three forces, okay, will first consume that, and only then my vehicle can accelerate. Say for example, if theta is 0, if your vehicle is moving on a flat road, then your theta will be 0. So you will be left with only two components. One is aerodynamic drag and the other one is rolling resistance. So that is how it is. So let me just go back to you